The drinks manufacturers reducing the sugar content of one of their fizzy drinks by 8% per year over the next 3 years. The sugar content of a standard can is currently 35 grams. Calculate the sugar content of a standard can after 3 years. Right, so the first thing we do is we're starting off with 100%. Now they are going to reduce the amount of sugar in that can by 8%. So when we take 8% away, we end up with 92%. Now we've got to think about what is 92% as a multiplier. In other words, what is it as a decimal? And it is 0.92. So that's the first thing that you write down on your paper. Now we're going to make up our equation. So we've got the amount of sugar, and from that we take our multiplier, which is that percentage value, which is 0.92. And it's been reduced over the next 3 years, so we take that to the power of 3. The time always goes up there, and then multiply all of that by the amount of sugar that was currently in it, which is 35 grams. Now put all of that into your calculator. We get an answer of 27.25408. Now check the question. Does it ask us to round to a number of decimal places? No, it doesn't. So I'll just round that to 27.3 grams. A pollen sample weighs 12 grams and contains 1.5 times 10 to the power of 9 pollen grains. Calculate the weight of 1 pollen grain in grams, giving an answer to scientific notation. Now stop thinking about this as just normal numbers. If it weighed 12 grams and there was 10 pollen grains, you would do the sum 12 divided by 10. So do exactly the same, but it's not 10, it's this number here, which is in scientific notation. So we have 12 divided by 1.5 times 10 to the power of 9. Now the answer to this turns out to be 8 times 10 to the power of minus 9. Now, your calculator might not give you it in scientific notation. If it doesn't, then you have to change it to scientific notation. Calculator might give you that number, so to change that to scientific notation, we have to move a decimal point until we get a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number between 1 and 10 is 8. And we've moved the decimal point 9 places, but it's a small number, so it's minus 9. For this one, the diagram shows a parallelogram. Now that means opposite sides are the same size and they're running in the same direction, so opposite sides will be the same vectors. Now AB is represented by vector U and BC is represented by vector V. Now the first thing I would do before I even look at what the question's asking is I would put in equal vectors. So if that's U, that's also vector U. And if that going in that direction is V, then going in that direction is also V vector. Now, we're asked to express from B to D in terms of U and V. Right, so if we want to go from B to D, we want to find a route where we can take one of the paths that is already marked with a vector. So from B to D, I can't go that way because I don't know what that vector is, but I could go from there to there and then across to there. I know what both those vectors are, so if we write them down, we end up with that vector there is V vector, and this one here is going against the arrow, so instead of it being U vector, it is minus U vector. Now, the other route we could have taken is from B to A to D. That is going against the direction of the arrow there, so it would be minus U and then plus V. Both are exactly the same vectors. This one here, we want to fully factorise this expression. So we've got 3x squared minus 48. There's two terms in it, so it could be a difference of two squares or it could be a common factor. Now, 3 is not a square number, 48 is not a square number, so it must be a common factor. So common factor is 3, which gives me 3 bracket x squared minus 16. Now, when you look at this, I can take the square root of that, that's a square, and I can take the square root of 16, which is also a square number. So make two identical brackets. Square root of x squared is x, put that in both brackets, and the square root of 16 is 4, but with a difference of 2 squared, one bracket is positive and one bracket is negative. It does not matter what order I put those plus and minus signs in, it is still exactly the same. Now for this one, AB and CB are tangents to the circle. So first thing I would do, if you know something is a tangent to a circle, highlight it in some way. So that's a tangent, and that's also a tangent. Now a tangent meets a radius at 90 degrees. So there is a radius there, coming from the centre out to the outside of the circle. So I know that this whole part in here is 90 degrees. Now that I know that, I can start doing the question. So first thing, we want to calculate the size of angle ABC. So from there to there to there, so it's this angle in here. Now there's only one piece of information I've got, and this here is 143. So I stop and I think, what can I work out? Where can I go from here? And the only place that you can work out an angle is this bit here. There's a straight angle, so it's 180 degrees. So if I take 143 away from 180, then I am left with an answer of 37 degrees. Now always do your sums at the side of the page. So in there is 37 degrees. Now, what can I look for now? There's parallel signs, so we look for Z shapes or F shapes. Now I'm going to pick out a Z shape. I'll highlight it so that you can see what it is. So there's a Z shape coming from there, across that radius and up to there. So that means that those two angles underneath that Z are exactly the same. So if that's 37, that bit there has got to be 37 in here also. Now, what do we do now? We know that a radius and a tangent meet each other at 90 degrees. The word for that is perpendicular. They meet at 90 degrees. So if I've used up 37 degrees in here, it means in here must be 53 degrees. If we now look at this final triangle here, that is coming from one point. Those lines are parallel, and that's two tangents. So that's got to be there an isosceles triangle, so that's also got to be 53 degrees. So the last thing I have to do is to add up the two angles I've got. So 53 and 53 gives me 106 degrees. And if I take that away from 180, then I'm left with 74 degrees for the shaded angle. Now, these questions are all about finding what you know and piecing it together. You piece one part at a time, and sometimes you might not get the final answer, but you will get working and you'll get marks for all of that that's written there. So please make sure you make some attempt at it and you write something down. Jack called his internet provider on 6 occasions to report connection problems. On each occasion he noted the length of time he had to wait before speaking to an advisor. The times in minutes were as follows, and we've got to calculate the mean and the standard deviation. Now, the mean is given this wee symbol here, x bar, and we add up all of the numbers and we divide by the amount that we've got. So we've got 13 plus 16 plus 10 plus 22 plus 5 plus 12. When I add all of them up, I get 78, and that's got to be divided by 6. 78 divided by 6 gives me a mean value of 13. Now, to work out the standard deviation, we set up a table. There's the standard deviation formula that comes from your information sheet, so you have that at hand when you're in the exam, and it leads us through what we need. So we start off with our x values, we'll list them down the side of the table. Then we want x minus x bar, that's that bit there, but we want to square them as well, so it leads us through this table. So x minus x bar for the first one is going to be 13 minus 13, and x minus x bar is 16 minus 13, 10 minus 13, 22 minus 13, 5 minus 13, and 12 minus 13. So when I work out x minus x bar, I get 0, 3, minus 3, 9, minus 8, and 1, minus 1, sorry. When you check to see if these are okay, see if you add up the positive ones, it should be the same number as the negative ones. So we've got a 3 and a 9 is 12. Here I've got a minus 3, a minus 8, and a minus 1, which gives us minus 12. So that should always turn out to be 0. If it doesn't, check your working. We now want to square them. So 0 squared is 0, 3 squared is 9, Minus d squared is also 9. 9 squared is 81. Minus 8 squared is 64. And minus 1 squared is equal to 1. Now, when we add all of them up, we get 164. Now, all it's left for me to do now is to stick them into that formula. So that is equal to the square root of the sum. There's a wee sum sign in there. And that's the sum of all those numbers. So it's 164 divided by n minus 1. So the number of numbers we have is 6. So when we take one away from that, we get 5. And if we work that out and take the square root, we get 5.7. Sophie also called the same internet provider on several occasions to report connection problems. Her mean waiting time was 15 minutes and standard deviation was 4.3 minutes. Make 2 valid comments comparing Sophie's waiting times and Jack's. Right, a wee table helps us work this out. So what we've got is Jack, the mean time for Jack was 13 and the mean for Sophie was 15. Now we've got to write down in context what that's all about. So basically it means that Sophie had longer waiting times. Right, so you write that down. So Sophie, on average, had longer waiting times. Now, the next thing we do is we now compare the standard deviation. Now remember, standard deviation is about consistency and it's about spread. The difference between the highest and the lowest is about the spread. So Sophie, the spread of her times where the standard deviation was 4.3, whereas Jack's was 5.7. Now what does that mean in terms of her waiting on these phone calls? It means that on average, the times that she had to wait were less spread out. So you could say the time Sophie had to wait was more consistent. That's the word to use, more consistent. And less spread out. And there should say the time Sophie had to wait. A carton is made in the shape of a large cone with a small cone removed. There's an important bit there. A small cone is removed from it, so that means it's taken away. So the large cone has a diameter of 32 and a height of 24 centimetres. Small cone has a diameter of 18 and a height of 13.5. So basically, to work out the volume of this carton, this darker part up here, it's the big cone and we've cut away the bottom one. So we're going to work out the volume of the small cone. Right, so volume of the small one, I've written up here the volume of a cone. It doesn't matter what order you do them in, I've chosen to do the small one first. So it's going to be 1/3 multiplied by pi. Now you can use 3.14 or you can use your calculator value, the full value, times the radius squared. Now there's the circle for the small cone, so the radius of that is half that distance, so it's going to be 9 squared. And that's going to be multiplied by the height of the small cone, which is 13.5. And it's all going to be measured in centimetres cubed. Right, we'll put all that into the calculator. Now, when you work all of that out, you end up with a value of 1,144.53 centimetres cubed. Okay, now we're going to do exactly the same for the volume of the big cone. So put all of the numbers into that and put them into your calculator. Now for this one, we've got 1/3 times pi, 3.14, times the radius. Now the radius of that big cone is this bit up here, so it's half of 32, which is 16. We've got to square it and we multiply it by 24. Stick all of that. That gives me 6,430.72 centimetres cubed. Now the only thing now we've got to do is the volume of the carton. So the volume of that has got to be 6,430.72 take away 1,144 0.53. That gives me 5,286.19 centimetres cubed. Now, back up here, give your answer correct to two significant figures. So to get two significant figures, we will underline the first two numbers, the 5 and the 2. Now, when I look to see what this 2 is, that is hundreds. So really, I'm rounding that to the nearest 100. So when I round it to the nearest 100, I get 5,300 centimetres cubed. A set of step ladders has legs 150 centimetres and 140 centimetres, so they're represented there. When the step ladder is fully open, the angle between the longer leg and the ground is 66, and we've got to calculate the size of the angle between the shorter leg and the ground, which is x. Now, in this question, it's not a right angle triangle, so it's not SOHCAHTOA, so it's either the sine rule or the cosine rule. Now, only one side is given there and one side is given there. So two sides, we know two sides, don't know anything about the third side, don't want to find it out. So all three sides are not involved, so therefore it is not the cosine rule, it's got to be the sine rule. Now the next thing we do is we have got to label this triangle, so I'll call it A, B and C. Use small letters, so that's small a, across from small angle C is small c, and across from B is small b, but I don't need that one, so I'm not really interested in that. Right, so sine rule then will be A over sine A is equal to B over sine B is equal to C over sine C. Now, we will tick the things that we know, and we'll put a wee star beside the one I want to find out. So I want to work out angle C, so a wee star goes in here, not at the top. Now tick the ones that we know already. So I do know small c and I know small a, so I can tick that one and I can tick that one, and I know angle A, so I can tick that one. So we can discard B, but we knew that already. So when I use A over sine A, I end up with 140 divided by sine A is sine 66, and that is equal to C, that's 150, divided by sine C, and that's what I want to work out. Cross multiply to bring everything up to the top, so 140 times sine C is equal to 150 multiplied by sine 66. So in effect, we're really undoing this step here. I want to leave the sine C here. Okay, so leave that there, and I've got 140 multiplied by sine C, so the opposite of multiplying is dividing. So sine C is equal to 150 multiplied by sine 66, all divided by 140. When I put all of that into the calculator, I've got to make sure that I write it down to at least 3 decimal places, but I would keep the full number in. So the number on your calculator should be something like 0.978998, and it goes on. Keep all of that in your calculator and do shift sign of the answer. So C is sine to the -1 of that number there. You've kept it in your calculator, and when you work it out, you get 78.18 degrees. Right, we want to complete the square, that's what that means. So what we do is we take the number in front of x and we half it, and that gives me the number in the bracket, this a. So I end up with x plus 4 all squared. Now this -7, just pull it down and leave it at the end. If I square this out, I get x squared plus 8x plus 16. There's no plus 16 in this part, so I've got to take away that last number squared. So I'm taking away this 4 squared. All I have to do now is to tidy that up. So I get x plus 4 all squared, and -16 minus another 7 gives me -23. Now that's the square has been completed. Now I'm going to put an extra part in here. This was not asked for, but you will need to know this. That's a parabola with a turning point of -4, -23, and that's what completing the square is all about, so that you can find the turning points of a parabola. So that wee part was not needed. but you will need to know it for your maths. Indices, we've got to simplify n squared all to the power of 3 multiplied by n to the power of 10. So when you're raising something to a power, that really means n squared times n squared times n squared. Now, the shortcut to do that is to multiply the powers as n to the power of 6. Now, we've still got to multiply by n to the power of minus 10. Now, what do when I'm multiplying indices? When I'm multiplying indices, I add the powers. So I'll get n to the power of 6 plus minus 10, which is minus 4. Now I've highlighted this part here. Give your answer with a positive power. To change that to positive power, we do 1 over n to the power of 4. Now that's a full mark for this. So make sure you express your answers in the form that they ask.